So then the last thing is really just vocab for like sound and light that you just kind of need. It sounds painful to start something now, but literally it's 2 minutes. Let's just have one board of sound and light properties, because it helps you do the homework if you know a little bit about what sound and light are. Let's see. Okay, real quick. And I've sort of said them a few times already. I just want to throw some numbers your way. Okay, here we go. Sound. I've said multiple times, there's a pressure wave in air. The only subtlety left is that it is not around zero. On Mars, it might be close to zero, but here, it's around atmospheric pressure. And la 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 like that. And this is position, and it's going this way in time. And how fast is it going? Oh, we'd have to apply the laws of physics to the gas law equation and do a bunch of calculations and have continuity in there, and we would get that it's 343 meters per second. So that's fast. It's not like ridiculously fast, but it's kind of fast. So up here we have pressurized air, and here we have rarefactorized air, right? So we lower the pressure above and below atmospheric pressure. When you go into a solid, it goes higher. So V, for water, you'll probably need this for some homework problems. And since some of you don't have the book, there's a number for you. And maybe you don't have the internet also. And then also here, that's in water. And then here, it's at like 6,000 meters per second for metal. So just to give you a little intuition, sound speeds up a lot when you have a condensed piece of material, right? In gas, molecules are missing and pushing on each other in the gas phase. They're really far apart. But in a solid, they're right next to each other. And when one moves, it pushes the other one really quickly. Okay. We hear, also to build your intuition, 20 hertz to 20 kilohertz. Depending on age, right, and other medical conditions, it might be different. You can probably hear higher than I can, although there's a fun demo when you turn it up higher and higher, and people still claim they can hear it, and then you show them you unplugged it like 5 minutes ago. So I should have done that to you, but we ran out of time. You can also, and then sort of the wavelengths here, you can also go ultrasound, right? That's this thing that can see through your body by how sound reflects back, which is velocimetry, which we're going to talk about, I think, Tuesday. And that's hundreds of kilohertz, so higher, ultra meaning faster, to megahertz. But then we could say, well, what's the wavelength? The wavelength kind of tells you what kind of imaging resolution you could get from an ultrasound. So I could say, what's the wavelength in an ultrasound if you're at 3 megahertz? Would be a question. So maybe you could do it lambda at 3 megahertz. You'd say, oh, I'm from Dallas. V equals FW. F lambda. And you'd say, what V would you use? Water. Are you most like air, water, or metal? I am totally metal, but you guys are mostly water. So 1480 is frequency, 3 megahertz. And you get that lambda is like a half a millimeter. Right? This is why you don't get sharp detail of your little nephew that's coming along or whatever ultrasound picture you've been looking at. Okay. Oh, I'm going to do light off the top of my head. I'll save light for next time. We don't have to do light. Light is really fast. Okay, that's the main thing to know. Okay.